This is number 14 from the review. We want to find the solution set, so we need to combine our two fractions and simplify first. So I'm going to bring the 2 over x plus 1 over to the same side of the fraction as the 3 over 2x plus 5. I'm going to give myself a little more room there. And now I need to find a common denominator. So again, fancy form of 1, I will multiply my first fraction by the denominator of my second fraction. So x plus 1, and whatever I do to the bottom, I have to do to the top as well. And then similarly, for my second fraction, I'm going to multiply it by the denominator of my first, 2x plus 5, over 2x plus 5. My new denominator is x plus 1 times 2x plus 5. And in my numerator, I'm just going to distribute. So here I need to distribute my 3 through 3x plus 3. That's why I always do these in parentheses. I always do these in parentheses so I can distribute and remember that it's not just times one of the terms. Here you have to be careful whenever you have subtraction that you take that negative with your 2. So that gives me negative 4x minus 10. And then I just need to combine my like terms of the numerator. I have 3x and negative 4x, that's negative 1x. 3 and negative 10 is negative 7. And my denominator we leave factored. So I have a 0 at my 0 comes from the numerator. I have negative x minus 7. When I set that equal to 0, that becomes x equals negative 7. My asymptotes come from the denominator. That's where my function is undefined. My asymptotes are negative 1 and negative 5 halves. So again, negative 7 was my 0, or x-intercept, and negative 1 and negative 5 halves are my vertical asymptotes. The next thing we're going to do is look at the graph so that we can tell what's going on around these and where our function is less than 0. When you graph the function in your graphing calculator, again, you want to take a look at the table as well just to verify your values. We were looking specifically at negative 7, negative 1, and negative 5 halves to see what's going on around those values and see where our graph is less than 0. Starting at negative 7, we have our 0 at negative 7, but to the left of negative 7, our values are y values are above 0. They are they're greater than 0, they're positive. So what we have here is that we're less than 0 from negative 7 to negative 5 halves. So in this interval here, we're less than 0. And then if you go to your table just to verify, we don't cross the x-axis anywhere as we go to positive infinity. So from negative 1 to positive infinity, we are less than 0 as well. So in interval notation, it's from negative 7 to negative 5 halves, and negative 1 to infinity. The little piece in the middle there between negative 5 halves and negative 1, of course, is greater than 0. And in set notation, between -7 and -5/2, and greater than -1. Again, make sure you're using your graphing calculator and looking at your table to verify your values, not just your graph. Remember, the graph, the picture you're looking at is constrained by your pixels, and depending on how good your calculator is, it's hard to see sometimes what's going on there.
Made with Doodlecast Pro.